And so the big question is, why have we opted for a circular saw? Firstly, a circular saw is handheld, whereas, a table saw is stationary, it lays flat. The circular saw is budget friendly. The table saw is slightly more expensive. You can make fewer cuts when using the circular saw, but with the table saw, you can make more accurate cuts. It's quite messy when you're using, the circular saw, with sawdust, but, the table saw tends to be a lot more cleaner. If blade selection is pertinent or at the very core of getting quality cuts, then we must be able to decipher or interpret technical data that is associated with the cutting blade. Technical data or jargon isn't as daunting as it seems once you get the hang of it. For the Guild power tool, we've got a blade size of 185mm, a blade bore at 20mm. It's got a cutting capacity of 90 degrees at 65mm and 45 degrees at 45mm. So it essentially means, it can cut at various angles up to a depth of 65mm or 45mm, depending on the angle. And also a bevel capacity that's capable of doing cuts, from anywhere between 0 to 45 degrees. So it could be 0, 15, 30 and 45 degree cuts, okay? At a later stage, I will be showing you how to set, the depth that you want to cut and the angle at which you want to cut, okay? But first, let's get conversant with all of this data. If you juxtapose the technical data information side by side with the information that you've actually got on your blade, we can instantly begin to see that there is a correlation. 185 being the actual blade size or the size of the rim, 20mm being the blade bore, which is right at the center of the blade, and 2.4mm is the thickness or kerf of the blade. At a later stage, I will show you how to adjust your cutting and bevel capacity. The next step would be to familiarize with other work tool components. When I push on the lower guard lever clockwise through the fixed guard, it reveals the bottom of the blade, and you can see that it is being rotated in the direction of both arrows earlier highlighted in the aforementioned. To change your saw blade, you need to take out the blade bolt and the outer flange with an Allen key, which then reveals the blade bore, the saw blade, and an inner flange behind it. Just remember that when fitting in a new blade, that the saw blade must be sat on the inner flange, okay? Suffice to say, the saw blade must be sandwiched between the inner and outer flange, with the blade bolt coupled onto the outer flange, okay? The tip of one tooth to the tip of the next tooth is called the step, while the gullet is the space in front of each tooth. Just take cognizance of the gullet, the size and its depth determines how much wood can be removed during cutting. In general, if a saw blade has fewer teeth, the speed rate will be faster and it will have a larger gullet size. And larger gullet sizes are most suited to rippling applications. But if you've got more teeth and smaller gullet sizes, then it's more suited to cross-cut applications. I'll show you what I mean in a minute, okay? Economy blades almost always have a thin stamped steel plate with expansion slots that end bluntly in open holes, which is what we've got here. The open hole exudes or signals old technology, and a noisy blade, whereas good quality blades have a laser cut plate, as you can see here, and the length and width of each tooth tip is bigger than the economy blades. The laser cut plates are designed for long life and the teeth can be resharpened many times. Here we have got an economy cross-cut saw blade, and you can tell by its stamped plate, open technology and fewer teeth, with a very small gullet or space between each teeth. And if we zoom out, the stamped caveat highlights that the saw blade rim size is 8.5 inches, the center bore 30mm, it's got a 40 teeth, and the kerf thickness is about 2.4mm with an RPM of 7,000. So, cutting or ripping applications is dependent on the gullet size and the number of teeth that you've got. But the number of teeth does not determine the quality of the cut or the purpose. Even though you may have often heard that you'd get smoother or finer cuts with a cross-cut blade and a rougher cut with a ripping blade. To get good quality cuts, you need a blade to do the job that you're doing. Here we've got a plywood strip that's been stripped off the plywood board, and you can tell by the layers, on the side. And so although you need a ripping blade to cut wood vertically along the grain of the wood, and a cross-cutting blade to cut across the grain of the wood horizontally, you might be tempted to think that getting a cross-cut blade to cut across the grain of both the strip and the plywood would be the best blade to get. And you might also be tempted to think that getting a ripping blade to cut along the grain of the wood vertically would be the best blade to get, when cutting the plywood strip and, the plywood board. But both the ripping blade and the cross-cut blade as standalones may not be the best solution to cut your plywood, as your plywood is a type of manufactured wood panel that's made by gluing veneers together. And as a result, there is that high propensity that the wood grain may be alternating on each other. If the veneer layers are glued with the wood grain of the plies at right angles to each other, suffice to say, when you're dealing with your plywood, the grain isn't homogeneous or uniform along the grain of the wood and across the grain of the wood, as there is a crossover of ripped grains and cross-cut grains. So using a dedicated rip blade or a cross-cut blade would not be the optimum solution to get quality cuts. You would be better off using a combination blade which has got about 40 to 50 teeth, or a general purpose blade. They don't rip as good as a dedicated ripping blade, or they don't cross-cut as good as a dedicated cross-cutting blade, but they do an adequate, pretty good job of both. Combination and your general purpose blades are anywhere between 40 to 50 teeth. This combination blade has got big gullets and in between fine tooth. Both the general purpose and the combination blade can serve as your optimum blade. If you find it laborious to change a blade, it gives you the added advantage of leaving one blade in your work tool. This is a quality tool as it's got laser cut expansion holes, which reduce noise and vibration, big ripping gullets, and fine cross-cut teeth, and extra large carbide teeth that allow multiple resharpening. So, do you choose a combination blade or a general purpose blade to get quality cuts off of plywood? The answer depends on the purpose, the woodworking that you do, and typically the type of material that you work with. Both of these saw blades fit the jack of all trade types. Suffice to say, an all-in-one blade for all cuts. This general purpose saw blade has also got a laser cut steel body. It is made of cold rolled steel and an extra thick carbide teeth that can take a sharper edge, stay sharp longer, and can be resharpened multiple times than most blades on the market. Both the combination and the general purpose have both got a chrome armor plating instead of painting, which helps with aesthetics, corrosion resistance, ease of cleaning, durability, and lubricity. The 40-tooth saw blade with a 30-degree alternate top bevel grind tooth configuration easily rips off hardwoods up to 1 inch thick and excels at cross-cutting hardwoods and veneered plywoods. It's also got, a resin-filled vibration dampening slots that helps to reduce harmonic vibration, and an extremely clean cut, tantamount or almost mimicking the extremely clean cut that you'd get from an 80-tooth cross-cutting saw blade. So what can we take from this? If you take a more incisive look and examine all manufactured boards, whether it be composite boards or man-made boards like your plywood, chipboards or medium density fiber boards, you will quickly come to the realization that their grain structure is haphazard or sporadic with respect to its grain structure, line of travel, orientation. As you can see, in this case, your plywood veneers, overlap or overlay each other. They go in different ways, which essentially means that your veneer sheets are sat on top of each other, and so you do not have a grain structure as you're always ripping or cutting, when you're using your saw blade. That's why it is recommended that you can use a general purpose blade or a combination blade to cut your plywood, which have a range of 40 to 50 teeth, or you can use a composite blade with a range of 60 to 100 teeth. An increase in the amount of teeth essentially means that, it will take a bit of more time for you to cut through your plywood, but, it does, a bit of cutting, a bit of ripping, not as your dedicated cross-cut blades or your ripping blades, but you will get better quality cuts with the composite blades. So ideally, a composite blade with a 60 tooth threshold value should be able to get quality cuts off of the plywood. And so now let's move on to some more simpler woodworking. For cutting natural wood, or in this case pine wood, we can clearly see that the grain structure isn't overlapping. It isn't random or chaotic along the grain of the wood and across the grain of the wood. And so you will need a dedicated ripping blade to run or cut along the grain of the wood. The ripping blades typically have about 24 teeth. They have large gullets between each teeth to move out big chunks of wood. So it essentially cuts long fibres of wood or moves out big volumes of wood when cutting. So essentially you need big gullets for reaping, to reap in the same direction as the grain to enable big chips come off the wood. If you cross-cut from the end grain with a reaping blade, you will only get tiny fibers off your wood. And that is because a dedicated ripping blade is not suited for cross-cutting. Do not use a rip blade to cut plywood, melamine or MDF. The quality of the cut will be poor with excessive tear out. Cross-cutting blades, on the other hand, typically have a 60 to 80 teeth range, and so with cross-cutting blades you want a blade that can cut across the grain of the wood, as exemplified here. Cross-cutting blades have fine tooth and more teeth with smaller gullets, so essentially you're cutting across the grain to achieve a finer cut. Do not use a cross-cutting blade for reaping applications. And that's because if the gullet isn't big enough, it may not be able to excavate material from the gut, which leads to overheating. And so for reaping, you want to use 40 tooth or less, or typically 24 tooth. And for cross-cutting, 60 to 80 tooth. And so here is a quick overview of the saw blades and their tooth range. Saw blades have got distinct tooth geometry. If we isolate one tooth, you can see at the top of the tooth, the kerf or the thickness of the tooth, the bevel or slope, the face of the tooth, and the gullet in front of each tooth, which can be different for different saw blades. For the alternate top bevel or ATB, you can see that the top isn't necessarily flat, but rather it is slopey and sharp and alternates to the left or to the right. Its teeth cut like knives and in effect scoring the wood to minimize tear out. And as you can see, the bevel angle varies. Increasing the bevel angle is tantamount to improving cut quality, but the durability reduces significantly. Your mundane ATB teeth are used on cross-cut, general purpose and some rip blades. To cut hardwood plywood, you're better off using an ATB whose bevel angles have been tilted to 30 or 40 degrees, steeply. At 30 or 40 degrees, they will cut melamine perfectly, without tearing the paper thin face veneers. But like I said, the quality of cut is improved when you increase the steep bevel angles, but you compromise on durability. But like I said, your regular ATB are more durable but provide less quality cuts as opposed to your high angle alternate top bevel, which provide better quality cuts but are less durable due to the steep angles. And lastly, for the ATB, you've got your alternate top bevel raker. The ATB raker's tooth configuration consists of cross-cutting teeth and ripping teeth in 5 tooth clusters. It is designed for both ripping and cross-cutting, and it is featured on the 50 tooth combination blade like we've got here, where the caveat reads 50 teeth. The next tooth configuration geometry is the flat top grind teeth. They are used mainly on rip blades where a fast feed rate is important to prevent overheating and where bottom side tear out isn't an issue, as the cut runs parallel to the wood fibres or along the grain of the wood fibre. The next tooth configuration is the triple chip grind. They have beveled corners on either side of one tooth and then alternate with an FTG teeth continuously throughout the circumference perimeter of the blade. Suffice to say, on the blade, the beveled corners alternate with the FTG teeth. They don't have scoring bevels as in the case of the ATB, so the TCG is very durable and is used on glue line rip blades, blades for melamine board, laminates and other manufactured materials, where tooth durability is most important. The TCG geometry is particularly suited or designated for particle board products and abrasive materials, like your melamine and MDF. Melamine can be used as the litmus test or acid test in determining, good quality cuts from your TCG. Suffice to say, if you get good quality cuts from your plastic or plasticized melamine, then there is a high propensity or likelihood that you will get good quality cuts of your veneered plywood using your TCG tooth geometry. Good quality cuts from the TCG on the melamine will often result in, a fine smooth cut quality along the top edge of the melamine, which will have pristine sharp corners, which is the pro. The con is, as the blade exits the bottom side of the melamine, it may chip off a little bit as it exits the plasticized bottom. Tooth hook, also called the rake, refers to the angle of the tooth face in relation to the center of your saw blade. Tooth with a positive hook cuts more aggressively. The rake or tooth hook for ripping blades is usually 20 degrees, whilst that of a typical all-purpose blade is between 15 to 20 degrees. The smaller the hook angle, the more pressure is required to feed your workpiece. Blades which have a zero rake or even still a negative rake are best suited for use on a radial arm saw, table saw and mitre saw because they prevent climb cutting and self-feeding. Sometimes you will find the hook angle caveats, labeled on your blades. In conclusion, your steep angle determines how steeply your tooth leans into the cut. So in choosing a saw blade, we've made the following considerations with respect to the application, the number of teeth, the gullet, the tooth configuration, and the tooth angle. Blades usually come in your conventional standard size 5.5, 6.5, and 7.25 inches, as well as other bespoke dedicated sizes from anywhere between 8.25 to about 10 inches. In this section, we will be reviewing 8 blades whose applications are for chipboards, composite materials, hardwood and softwood. This blade has got a 20mm bore, 9200 RPM. The rim size is 165mm or 6.5 inches, and the kerf thickness is 1.8 mil. It's got 24 teeth, which means it's particularly suited for ripping wood. It has latch gullet, so you'll be getting coarse cuts. It's got stamped caveats on its steel plate. It's got, the open expansion technology, which is the old technology, so it's going to be noisy. But you probably would be able to get the job done in no time, as you'd probably get fast, coarse cuts, get long fibers off your wood. Along its grain, the next blade's rim size is 165mm or 6.5 inches. It's got a 20mm bore, 9200 RPM, a 2mm kerf, and 40 teeth. It's got more teeth, but it is at the threshold for ripping, so it can be used for medium ripping and cross cutting. It could either be a combination or general purpose blade, but there is no way of telling without opening up the packaging. You should get a fast cut, but will be noisy, as it is the old technology with open expansion slots. The next blade has got a slightly larger rim at 185mm or 7.1/4 in comparison to the blades 1 and blades 2. It's got a kerf of 2.2mm, 20 teeth, and a 30mm bore with an 8200 RPM. 20 teeth denotes a ripping blade, and fast cut. I wouldn't be using this for medium ripping and cross cutting, but solely as a dedicated ripping blade. It's pretty much up to you. The next blade's rim size is 185mm or 7.1/4. It's got a 2mm kerf and a 20mm bore. It's got 36 teeth, which means it's got more teeth than your conventional 24T ripping blade. And the gullet here would be a lot more smaller. And again, it's closer to the lower limit threshold for combination or general purpose blades. So this blade should give fast cuts, and can be used for medium ripping and cross cutting. And you should have a more refined coarse cut finish. The blade on the inside could be a ripping blade with more teeth and a smaller gullet. The next blade has got a 210mm or 8.1/4 inch rim size, a 2.2mm kerf, a 7200 RPM, and a 30mm bore. It's got 20 teeth, which connote a coarse cutting, and a ripping blade with large gullets. HS means high speed steel, and HW on all saw blades connote a robust tungsten carbide. For longevity and fast cutting, it's pretty much adept for all types of wood, laminates, and plastic. The next blade has got a 210mm 8.1/4 inch size rim, a 2.2mm kerf, a 6500 RPM, and a bore of 30mm with smaller gullets. Can be used for medium ripping and cross cutting, so I'd be more inclined to say this is a general purpose blade or a combo or combination blade. The next blade has got a 10-inch or 254mm sized rim, a 2.5mm kerf, and a 30mm bore. 6000 RPM and 40 teeth, so could be a combo or a general purpose blade. The last blade has got a 250mm or a 10-inch sized rim approximately, a 2.8 kerf and a 30mm bore, an RPM of 6000 and an 80 teeth, which implies that you really could be getting a fine cut off from this blade with 80 teeth. It could be a general purpose, a combo or composite blade. And although all 8 blades are recommended for chipboards, composite materials, hard and soft wood, some blades are particularly more suited for natural wood and some for man-made manufactured boards. They have all got the open expansion slots and stamped steel, so they are noisy and economy blades. And so next we will be reviewing some DeWalt saw blades. We've got one 40 teeth saw blade and two 24 teeth saw blades, all of which have got a 216mm rim and a 30mm bore center. Each blade has got open expansion slots, so they're more prone to vibration, noise and blade warp. It is more probable that the 40 teeth is a combination or general purpose blade, as it's got, smaller gullets. And 40 teeth falls within the tooth configuration for a combination blade. The other two blades have got 24 teeth or fewer teeth with larger gullets and maybe more suited for ripping applications. All three blades are economy blades. The combination blade may not rip or cross-cut as good as a dedicated ripping or cross-cut blade, but they will do a pretty good job of both. And like I said, the 40 teeth combo or general purpose blade is the optimum blade if you want to leave one blade, in your tool, as opposed to changing your blade every now and then, especially if you find it laborious to do so. Next, we're going to look at 5 Freud quality blades. This 24 teeth saw blade has got a 190mm rim diameter, a 2.4mm kerf and a 30mm bore. It's got a 15-degree bevel and a 15-degree hook or rake angle. The 15-degree positive hook or rake angle essentially means that the blade would cut more aggressively. The blade deploys a laser cut expansion slot, which essentially helps to reduce noise and vibration and also helps to prevent warp. The laser cut expansion slots are resin filled slots. The 24 teethed or tooth blade essentially means that it's more suited for ripping applications. But if we also take cognizance of the positive rake or hook angle at 15 degrees, it could also indicate that it is a general purpose blade, as the hook on a typical all-purpose blade is anywhere between 15 to 20 degrees. Whilst blades designed specifically for ripping applications are usually 20 degrees. So essentially, this is an all-purpose blade. You'd get great finishes for your ripping, and you can use to, cut along and across the grain of the wood. If you also want to cross-cut, okay? So it will do a pretty good job of both ripping and cross-cutting. But you might be better off using this as a ripping blade, as it's got larger gullets and can extend the application for cross-cutting, as it's got a positive rake or hook angle at 15 degrees. The blade teeth is made up of titanium carbide, which is extremely harder than your tungsten carbide. They tend to provide fast, no chip and perfect cuts. This blade is particularly suited for cutting along and across the grain of woods. The positive hook angle essentially means a faster feed and more pull on the blade, as opposed to a negative hook angle which prevents climbing of the wood or self-feeding of the wood. It's also got a Perma shield incorporated, which withstands the toughest applications and provides thermal insulation. The Perma shield also helps to protect against corrosion and eliminates resin buildup, thus reducing downtime for cleaning. The next quality blade has got a 190mm rim size, a 30mm bore, a 2.4mm kerf and a 48 teeth blade. All them blades shown in this exposition have got the laser cut open expansion slots, or resin filled slots, which indicates that they are quality blades, as opposed to economy blades, which have got the open hole technology and stamped blades with small teeth. This quality blade has got bigger teeth or tooth sizes. It's got a hook or rake angle of 10 degrees, so it's not a very aggressive feed, as the smaller the hook angle, the more pressure is required to feed the workpiece. The previous blade has got a slightly more aggressive feed, as the hook angle was 15 degrees. Suffice to say, blades with a 0 or negative hook angle are better suited for your radial arm saws and mitre saws because they prevent self-feeding or climb cutting. The blade type tooth configuration is an alternate top bevel, as the bevel tooth angle is 15 degrees. In general, an alternate top bevel tooth configuration, which falls within the range of 10 to 20 degrees typical, is an all-purpose ripping and cross-cutting blade. And so, if the bevel of this blade is 15 degrees, I would be inclined to say that this is an all-purpose ripping and cross-cutting blade, okay? Which can be used for medium ripping and cross-cutting. And that's because an optimum ripping blade has got about 24 teeth, whilst a cross-cutting blade is anywhere between 60 to 80 teeth. This quality blade has got 48 teeth, which means that it does a moderately good job of cross-cutting and ripping, but not optimally. Okay, it's not a designated blade, but rather a general purpose blade with small gullets. The third blade is an interesting one. It's got a 216mm rim size diameter, a 2.4mm kerf, and it's 24 teeth with a 30mm bore center. It's got a negative hook or rake angle of -5 degrees, which means it's perfect for table saws, radial arm saws, and mitre saws, as the hook angle prevents self-feeding or climb cutting, which necessitates adding more pressure to feed the workpiece. The bevel tooth angle is 15 degrees, which falls within the alternate top bevel 10 to 20 degrees typical range. So this can be classed as an all-purpose or general purpose ripping and cross-cutting blade with large gullets. So just because it's got 24 teeth, it doesn't necessarily mean that it is a designated ripping blade. On the contrary, the bevel tooth angle at 15 degrees connotes that this is an all-purpose or general-purpose ripping and cutting blade. But if the blade type was a flat top grind with a tooth angle bevel configuration of 0 degrees, then it would have been more suited to say that this was a designated ripping blade, which would enable fast ripping and rough cross-cutting, but this is not the case, okay? This is a general purpose blade with an alternate top bevel tooth angle configuration of 15 degrees, which can be used for ripping and cross-cutting. The next blade has got a 250mm rim size, a hook or rake angle of 20 degrees, a bevel of 15 degrees, a 2.8mm kerf, and a 30mm center bore. So, at first glance, the 24 teeth suggest it is a ripping blade, but when you look, a little bit further, the bevel at 15 degrees suggests it is an all-purpose ripping and cross-cutting blade, but not so fast. The hook angle on a typical all-purpose blade is anywhere between 15 degrees to 20 degrees, whilst blades designed specifically for ripping are usually 20 degrees. With 24 teeth configuration, the hook angle on this blade is 20 degrees and it's got large gullet sizes, so I'd be more inclined to say that this is a ripping blade. And so, although the bevel is 15 degrees, which connotes a general purpose ripping and cross-cutting blade, I would be more inclined to use this as a ripping blade, as you've got large gullet sizes, 24 teeth, and a hook angle of 20 degrees. The next quality blade has got a 216mm rim size, a 2.4 kerf, 48 teeth, and a 30mm center bore, with a -5 hook angle and a bevel of 15 degrees. The negative hook angle connotes that this type of blade would preferably be used on a table saw, and the 15-degree bevel connotes an all-purpose ripping and cross-cutting blade with an alternate top bevel configuration. All of the 5 quality blades displayed are specifically for working wood, as you can see on the reverse of the label, where wood is highlighted specifically for them blade types. And you can also see that all blade types and teeth are made from titanium carbide. So when selecting your blades, apart from the type of material that you're cutting, take cognizance of the gullet sizes, the number of teeth, the hook angle, the bevel, and what your blades are specifically designed for, in this case wood. So now let's take a look at some other designated dedicated blades, and here we've got the TCX 15 Universal Turbo Segmented Diamond Blade and the TC10 Diamond Blade. The TCX 15 is specifically recommended and designed for cutting concrete products and general building materials, including bricks, blocks, pavers, and concrete roof tiles. Whilst the TC10 General Purpose Diamond Blade is also ideal for cutting curbs and slabs, bricks, concrete pavers and blocks, roof tiles, and general building materials. So both the TC10 and the TCX15 are not specifically designed for cutting wood. At first glance, the blade in the circular saw working tool is an economy blade that can be used in cutting wood. It's got 30 teeth with large gullets. Blade installed in the Bosch working tool, which bears the trappings and hallmarks of a ripping blade. But we will be more definitive, in working out if it's a ripping blade once we assess, the bevel and the hook or rake angle. The next blade at quick glance is a blade installed in a DeWalt working tool. It's got 24 teeth, which connotes that it's best suited for ripping. But again, the hook angle and the bevel would help identify or highlight specifics. And so now back to the blade in our Guild working tool. It's got a 2.4 Kerf, a 20mm center bore, and a 185mm rim size. And so this is the center bore. You undo it with an Allen key if you want to change the blade. Okay, so again, that's your rim size at 185. Your center bore is at 20mm, and your Kerf is at 2.4. This blade has got 24 teeth. And it's got large gullet sizes between the teeth, which means that, it can be used to move out, big chunks of wood. 24 teeth typically connotes a ripping blade, and you can see on the blade, it's highlighted that this blade is designated for cutting wood. You also have to wear your ear protection or muffins, your face mask, eye protection or safety glasses. Just pretty much take health and safety precautions. And ensure that you read the instruction manual. The National Institute of Occupational Safety and Health recommends that hearing protection must be worn when operating tools with a sound pressure level above 85 dBA or decibels noise level. And you can tell this is going to be a noisy blade because it adopts the open technology, here. The long-term goal of Niosh is to reduce the noise-induced hearing loss in occupational settings. And so, if you want to choose a quiet blade and the appropriate hearing protection, you can check the Niosh database for recommended sound power levels in terms of vibration of the work tool, as well as the sound power levels for the loaded and unloaded conditions of the work tool to choose the appropriate hearing protection and to estimate the noise exposure. The blade installed has got a small teeth, and the tooth configuration is an alternate top bevel. The stamped blade doesn't categorically state the hook or rake angle, neither does it state the bevel angle. But we can assume that the alternate top bevel angle is anywhere between 10 to 20 degrees typical. And that's because an alternate top bevel, which is used for all-purpose ripping and cross-cutting, typically has, a bevel angle of anywhere between 10 to 20 degrees typical. The kerf for each tooth is about 2.4mm in thickness. And here you can see that the blade, which is usually protected by the lower blade guard, extends below the base plate. And you can see that the blade has got large gullet sizes between each tooth. You know, the ATB or the alternate top bevel is suited for ripping. The 24 teeth is suited for ripping, but it essentially isn't suited for cutting strips from hard plywood. So we can see that this ripping blade has got a positive rake angle of anywhere between 0 to 20 degrees, and that's because you can see the inclination of the teeth or tooth. You can also use, a flat top grind, an alternate top bevel, or a TCG configuration for rip blades. But for hard plywood, you will be better off, getting a combination blade or a composite blade. And that's because the grain structure on your hard plywood is not uniform, it's haphazard. And so, your composite blades or your combination or general purpose blade will do a pretty good job of ripping and cross cutting at the same time. So, what quality of cut can we expect if we proceed to utilize this ripping blade to cut strips from the hard plywood? I'd be expecting, a somewhat poor quality cut, with excessive tear out in certain places. I would also be expecting overheating, okay? So I would be using it to get the job done, but not overly extensively, as I do not want to compromise on the integrity of the blade. I would try as much as possible to keep my hands steady, whilst cutting strips off of the hard plywood. And I will also be adding 3mm to the depth of my cut so that the blade can cut through the hardwood plywood material at the base here. And with the open technology, around the rim of the blade, as exemplified at the base here, you should be expecting a very noisy operation of the work tool, okay? As this is not a quality blade, it is an economy blade. So just a quick recap, when you're trying to get quality cuts, the blade selection as well as the type of material that you want to cut is very important. Here we intend to get strips off of hard plywood, and so the ripping blade with latch gullets, or the open hole technology isn't the ideal blade for getting strips off of hard plywood. You should be getting a tooth configuration that's got the ATB, which is the alternate top bevel, as well as a combination composite or general purpose blade due to the grain structure of the hard plywood. Click on the link in the description for quality blade material and tooth configuration selection in order to get quality fine cuts, as well as dust extraction configuration or customization, how to use the power rail guide, and risk assessment when using your circular saw. And that's about it really. If you found the information useful, don't forget to subscribe, like and share, helps the channel grow, and hopefully catch up with you later. Goodbye.